Hello and welcome back to your first steps in Unity. In this episode, we're going to talk about animations, take a closer look at rigid bodies, and start to write our very first C# script. Without further ado, let's jump right in. First, let's take a closer look at the goal. I put it inside the level component and added two components, the sprite renderer and the box collider. Now the transform, the position, the scale, even the color can be totally different for you, no matter what your preferences are. I choose green because it's the same color as the player. So with this, I want to indicate that these two have to meet each other at some point in time. But if you want to choose a yellow or whatever color, it's totally fine as well. Now that we have every single thing in place we need, it's time to give it a little bit more life. So you maybe know other games where you need to focus on something specific. It usually is done through multiple things like perspective or color or whatever. And one thing is animation. So if something is moving, you, the player, already knows, oh, there's something I need to focus in some kind on. It can be a trap, it can be pretty much anything. For us, it's the collectible. So we want to move it up and down a little bit to focus the player's attention on that collectible that, well, he needs to collect it. So to do that, let's first select a collectible, move out a little bit so we have a better overview, and now start the animation. To do that, we need the animation window, which is under Window, Animation, Animation, and it opens up another window right in our face. So let's reposition it for a little bit to right next to Project so it doesn't block our view too much. Now, with the animation window, we can create an animation clip. And that's exactly what we are going to do now. If we hit the create button, the window notices where our selection is. So if we try to do it on the goal, where we are trying to animate the goal. If we are doing it on the collectible game object, we want to animate the collectible. And in this case, it's exactly what we want. So select the collectible, hit the create button, and a pop-up comes up. And we create a new folder in our assets, animation, to keep everything organized, and call it collectible animation. And we created the animator component on the collectible game object. And that's basically what we need for now. Now keep in mind this is a very basic animation we're going to do. So let's not talk about different animation clips, like maybe we want something different to happen depending on the time, but only the very basics of the animation. And in our case, that's a simple keyframe animation. So we have a position in time where we want to have a specific position on the X and Y axis. Um, so a keyframe is a frame which holds the information where something should be. Now, if you have multiple keyframes over the course of a specific time, the editor is nice enough to interpolate between these things, but we will get to that in a minute. So what we want to do is to move the collectible up and down a little bit. Now, we don't want to move the whole collectible because this would be changing the actual position. We want to move the one inside, which is currently at 0, 0. So we start creating a keyframe by hitting the record button in the animation window, which now starts to think, okay, where are changes? What is currently changing? It can be basically anything. Over time now, in our case, we want to animate the y-axis, so it's a little bit up or down or wherever we want to start, and then up again. So at our first point in time, the starting position, we want it to be -.2, let's say. And in the middle, we want it to be at .2. So it's moving up and down. Now, you don't have to do it by keys. You can do it as well with the normal move tool. But usually it's a bit, well, I'm not good enough to move it smoothly up and down, so I will have some interference on the X or Y axis, which I don't want. So I like to work with the number keys. So, oops, .2. And now we have 2 points in time where we animate from one to the other, and the editor interpolates between those points. So we can stop recording and take a closer look. At the left side, we see where we changed something. So from the view of collectible, it's the inside position. So inside is the name we gave it. So if I would go with a different name, it would have the different name inside. So it's the game object name and what we changed on the game object. And here we changed a few things. Now the position is something we can only change as a tuple of 3. So we can't just change the y-axis. So we always have to change all 3 together. And that's exactly what we did. So we have the starting point, -.2, and the end point. Now, if you notice, the um, interpolation between these 2 points isn't like a straight line. Now that's because animation isn't a straight line. Like we have to accelerate in a specific direction and we have to decelerate when we start to stop. Sometimes we want a straight line, but in most cases the animation will start a little bit slowly, then keep on increasing its speed, keep on going, keep on going, keep on going, and then at some point it has the max speed and starts slowing down again. Now, if we want to change this behavior, we can work with the curves down here, where we see the curves. Now, they're not really good visible, so we hit the Shift key and scroll with the mouse wheel closer because -5 is the axis and that's too far away. So we go closer, it's .2, and now we can see the curve. So if we totally want to, we can start to change these, make them a little bit, well, more linear or something like that. But for most animations, it's a good way to simply have this kind of curve. It's some easing. To make it feel a little bit more alive. So let's keep it at this, switch back to the drop sheet, and now play the animation. You notice that it's moving up and then drops back down. So the animation will take place and then it doesn't know what to do. It just says, oh, the next information I have is, well, basically start at the very beginning. And the very beginning is, in this case, -.2. So it will jump right there. Now we don't want that. We want to move it up and down, both in a smooth way. So we can go again with the recording, of course. Or we can say, well, this is the starting point, and we can simply copy the keyframe with Control C and position where we want to be on our time axis, and Control V, and there we have another keyframe, which is now the third one we needed at the start, middle, and the top. And now we have a smooth animation between these points. So if we hit play to preview it, we can see it moving up and down a little bit over time, which is exactly what we want to achieve. So reset it with the preview button, and we're basically done with the animation. Now, keep in mind, animation is a really complex thing. It can do many more things. We could start to animate the color. We could start to animate the sprite even. We can do, well, a whole lot of different things. But for this course, it's best to focus on the simple things, which is a little position animation up and down. And that's basically it. So let's head on over to the collectible. Now we have the prefab change, or one instance of the prefab change. And now we want to apply that to every single one, because right now, if we hit start, let's focus on the collectibles a little bit. We switch on over to the game view and we see the one collectible we changed which is this one. It's moving up and down and it looks fine. So now we want to apply that to the others. So we go to the collectible prefab and hit overrides and apply all. Now you might notice that the animator is the thing we actually do want to change. So we can do it selecting this single one and apply to prefab collectible. And now check on the other one, which is the transform, which did change at some point in time, but didn't actually change. So if we open it up, we see the prefab, which is 0, 0, 0, and the position 0, 0, 0 as well. So the editor only noticed there was something different. It doesn't recheck if it's still different. So we can revert or apply it. It's basically the same. I will go with revert. And now our collectibles, all of them are moving up and down a little bit. So if I hit play, I see all of them moving up and down. And I can go in the scene view as well. So it's applied to every prefab, which is really good for the template. Okay, so yeah, that's basically it for the animation. Next up, the rigid body. The rigid body is a component which we can apply to a game object to tell the engine, okay, this object is part of the physics part of the game. So we want forces to be applied to it, or apply forces if necessary. So like gravity or something. If we hit the player and add the rigid body 2D component, now this object will, well, fall down and work the way we would expect an object to behave if it has a mass or something like this. So I will simply remove it for a moment just to verify that our game object, nothing happens. It's staying the same. And if I now put on the rigid body, we see that it's falling down. Now, this was pretty fast, so let's move it up a little bit. We see it's falling down, and it does that in a typical gravity manner, so it doesn't fall with the same linear speed all the time, so it applies to regular physics. So if we start falling, jump out of a plane, we accelerate through time. Then we, of course, open the parachute, so we decelerate at some time, but for the beginning, we start on falling down the whole time. Now, why don't we fall through the ground? That's because of the box colliders we attached before. So if we hit the floor and, well, simply disable the box collider, we just start falling through the game. If we check on the player, we see that the y-axis keeps on increasing. We can of course put it back up, but it's way too fast to actually see. So maybe 10, and there we maybe briefly saw it, but it's basically done. So let's stop it again and see that the floor has it re-enabled because we stopped the play mode. So every change uh, went back we made. So now we have a player with a rigid body and the ability to fall onto the ground. And yeah, that's the basics about the rigid body. Now, if we take a closer look at the component, we see that there are different possibilities to work with this component. The first one, the body type, is either dynamic, so it's a real dynamic object. It applies to forces, etc. The next one would be kinematic, which means it's only changed through script, through us. Or the last one, static, it doesn't change at all. It's staying right where it is. And yes, it has a border and stuff, but if we hit play, it doesn't fall. The same goes for the kinematic because we don't change it. So if I change it to kinematic for a moment, it just stays the same. If I go with dynamic, well, it's falling down. So dynamic is the thing we want. And now we can think about the different things. Let's skip over these because, of course, we can increase the gravity, the mass, whatever. Collision detection can be a bit problematic depending on how fast an object goes. So we can change it to continuous and different stuff. But the basic or the reset values, so if we go with the simple adding it, are pretty much all we need. So in this case, it's pretty much done. Now, if we start rotating, let's say for 25 degrees, we will notice that the body will, of course, fall down and then hit the side. So let's check that again. I'll move it up and let's say again 25 degrees and then play, and it's falling down and hitting to the side, so it's now at 0. Now sometimes we don't want that because actually I want my little green block to stay pretty much the same time always. So if I move it around, it doesn't fall over these things to change the z-axis. So I can hit the constraint and say, well, don't change the rotation. So if I hit the constraint on z-axis and re-hit the play button, we just simply fall down. And that's it. We don't rotate because we say, well, this is actually part of my game object. I want it to look like this. So constraints can be used to achieve a fixed thing on this on that axis, and helps reducing the overall weight in calculation. So again, a little bit of performance optimization if we want that, if we simply constrain it, because we don't have to worry about it and we don't have to calculate it. So that's it for rigid bodies. And now we have an object which applies to physics. Now, physics on their own are already pretty great, right? But we still need a way to control our character. So if I hit the spacebar, it should jump up. And sadly, there isn't a component which can do exactly the things I wanted to do. And that's where C# scripts come into play. Now, there are again multiple methods how to do it. The first one would be to create a script by going add component and go with the name of the script I want to use, for example, player controller. Hit the new script button, use the name of the script, of course, and hit create and add. Then the engine creates the script in the background and adds it as a own component. Now the script is located in the project folder, and we should rearrange it, of course, scripts, and put it inside our scripts folder. And now we have our component to control the character. Now, without any logic to it or without anything we edit ourselves, it doesn't do much. So right now we, well, don't do anything. But this is a good place to start with the programming. But first, let's take a closer look at what is created by the engine to use it as a component. Open up Visual Studio and we see the default creation, which is a class. We just named it player controller. It derives from monobehavior, which is a class by the Unity guys, which it needs to derive from to be applied as a component. And we have two methods already inside to help us start. Now, the first one, the start method, is called, as the comment says, once at the beginning of everything. So if we want to do some setup things, it's the right place to go. Then there's the update method, which is called once every frame. So all the calculations we do continuously should be inside this one. Now, those are only two methods. There are many, many more, but for the beginning, let's start with these two. The engine itself handles when they are called. So if we write something here, it's called at the start. And if we write something here, it's called every update. And to verify that, let's go with the console. To use the console, we use a class by the Unity engine, debug.log, which is a call to the console. And we write a string, which is hello, I just started. And this will be called at the start. Then for the update, we do the same, but with updated, so we can see when and how often it's called. Now, it doesn't do much yet, but if we hit switch over to the editor, we can now hit play and very fast stop, because the update is called very often and I don't want to flush the console that much. We see in this, what was it, half a second, we already logged 191 times. And the very first one was, hello, I just started, at the player controller start method at the player controller script, line 10. And after that, well, a whole lot of times, all in at 12:26:57. Hello, I just updated. So here we can see player controller update and player controller script line 16, and it's exactly where we just input these things and where we can start from. Now that's it for this episode. We animated our collectibles to move up and down over time. We hit our player with a little bit of physics through the rigid body component, and we created a component ourselves, the player controller. The next episode will focus on C# scripting, so keep that in mind before tuning in. Now, if you have any questions left, feel free to comment. I will do my best to answer them as fast as possible. And thanks for watching. I'll see you guys next time.